Hello viewers, you are watching Ben Academy and under differential calculus. We are now in lecture 02, differentiation from first principle. If you have not watched lecture 01, you please do, because there I introduce differentiation, the definition of differentiation and notation. So if you are ready, we want to go into differentiation from first principle. Differentiation from first principle involves using the knowledge of limits. And let us still define it that dy dx is equal to limit of change in y upon change in x. As change in x approaches 0 is equal to limit of f of x plus change in x minus f of x change in x as change in x approaches 0. Remember that in my first lecture, lecture 01, I defined the derivative of a function. So the derivative of a function using this particular definition is called differentiation from first principle. And to differentiate from first principle using this, you need to be guided. There are two approaches, and I'm going to give you the two approaches on this lecture series 02. In the first approach, there are steps. The first approach, if you don't like the first approach, you can also use the second approach. In the first approach, you will first of all, there are steps. There are steps. Step 1. Let me write step. Now, step 1. In step 1, you must first find f of x. And the f of x will be given to you. Now, by the first approach, there are steps. The first step is you state the function. The function will be given to you. F of x. You write the function down. And step 2. In step 2, you now find f of x plus change in x minus f of x. You find their difference. In step, please go back, please. 1, you state the function given to you. The function is f of x. That is step 1. Then step 2, you find x plus change in x. This notation here means change in x. Delta means change. So if I now write delta x, it means change in x. I will define this as the difference, x2 minus x1. So you now find f of x plus change in x. That is step 2. Then step 3. In step 3, you find the difference of f of x and f of x plus change in x. And I'll write this as f of x plus change in x minus f of x. When you find the difference, you are through with step 3. Then step 4. In step 4, you will divide this difference by change in x. That is f of x plus change in x minus f of x divided by change in x. That is step 4. Then step 5. In step 5, you will now find what is called rate of change. The rate of change measures the change that occurs in y given x. The rate of change is given as change in y upon change in x. So the change that occurs in x with respect to what? X. And that means we have to divide, because this particular expression here is change in y. So we have this as f of x plus change in x minus f of x all over change in x. So I'm plotting what is called rate of change. Now, having gotten the difference, the next is to find this quotient, this difference divided by change in x. And when you do that, you have gotten what is called rate of change. Rate of change is defined as change in y upon change in x. Finally, you can now find dy dx. That is step 5. You find dy dx. And how do you get that? You write dy dx by taking limit of step 4. We take limit of step 4, we have limit of f of x plus change in x minus f of x all over change in x. As change in x is approaching what? 0. Once you do this, if the limit exists, it means you have differentiated the function with respect to x. Right now, we want to demonstrate how to make use of the formula for differentiation from first principle to solve the example here on the board. The example says find the derivative of the function. We have I, y equal to 5, that is a constant function. Y equal to 3x squared. And we are told to find it, differentiate it from first principle. We'll start. We have solution. Again, that means takes the formula or the definition of the derivative from first principle. And it states that dy dx is equal to limit of f of x plus change in x minus f of x all over change in x as change in x is approaching 0. So by the steps which I have outlined, we will now solve the first problem. The first problem is there, and the first step says find f of x. F of x will be given to you in any problem. And in this particular problem given to us, our f of x is y, and the y there is equal to 5. So that is given, and we are through with step 1. Having done step 1, let's now move to step 2. In step 2, we will now find f of x plus change in x. And let me explain this. Now, if I have a function given to me as f of x, if there's any input, or if there is any number with substitute in place of x, there will be a corresponding output. For example, if I have f of x is equal to 6x, if I put 2 here, or if I substitute 2 here, 2 will definitely appear here. So if there is an input, the input is 2, there will be a corresponding output. And the corresponding output is when you replace x by 2. So that means 6 times 2 is equal to what? 12. So if input x equal to 2 is here, there will be a corresponding output 12 by times 6 by 2. So anything that is here will also appear here. But for a constant function, if I have f of x equal to 5, any value I substitute in place of x will definitely give me that same constant. Any value I put in place of x will give me 5. If I put 5 here and if I put 6 here, the answer will be 5. If I put minus 2 here, the answer will be 5. If I put half here, it will be 5. If I put x plus 2 here, it will still give me 5. So for our problem, if I put x plus change in x here, x plus change in x, it will also give me 5, because the functional value of a constant function will always produce the constant. So for my step 2, I want to now find the functional value of this for the function f of x equal to 5. Let me do that now. So therefore, I have f of x plus change in x is equal to just 5. And I'm through with what? Step 2. Next is to move to step 3. Step 3 is you now find the difference of step 1 and step 2. And if you do that, you have gotten what is called change in y. That is to say, change in y is f of x plus change in x minus f of x. And if you do that, you have The answer I got for f of x plus change in x is what? 5. 5 minus the answer or the functional value or the value of this function is also 5. I put 5 there. When I subtract, I will get what? 0. So since I've gotten 0 or the last answer, I'm through with step 3. Again, we run down of these 3 steps which I've so far done is first to find f of x. When you get f of x, you get f of x from the problem given to you. The question that is given to you is the function. So you place f of x there, the value of the function, which is 5. Then step 2, you find f of x plus change in x. Meaning anywhere you see x, you replace it by x plus change in x. And I've done that, no longer x, but x plus change in x will still remain 5 because it is a constant function. Step 3, you find the difference of the last 2 answers you have gotten. And here we have it here. 5 minus 5 is equal to 0. Next, we now move to step 4. Step 4, in step 4, you now find rate of change. The rate of what change is equal to change in y upon change in x. In other words, the last answer I have, I will divide it by change in x. This is equal to change in y is what? 0 upon what? Change in what? X. And this answer is equal to what? 0. Now at the end of step 4, we'll now move to step 5. The last step, and I want to play the board. The last step, in the last step, that's step 5, we'll now find the instantaneous rate of change. The instantaneous rate of change is when you take limit of this as change in x is approaching 0. And we write this in symbol as dy dx equal to, you take limit of this, limit of change in y upon change in x as change in x is approaching 0. And we also write this in functional form as limit of f of x plus change in x minus f of x, f of x all over change in x as change in x approaches what? 0. Alright? So that means at this particular point, you now substitute the last answer we have gotten. And the last answer there is, the answer for the numerator is limit of course we have divided change in f of x plus change in x minus f of x, which is 0, divided by delta x, we have done that, the answer is 0. So I have 0 as change in x approaches, okay, is equal to the limit of what? 0, as change in x is approaching what? 0. And the answer, of course, the answer is equal to what? 0. Because if you take limit of a constant, it gives you the constant. So what we are trying to say here is that if y, which also means f of x, is equal to 5, then dy dx will be equal to what? 0. So we are trying to establish one fact, that whenever you differentiate a constant, the answer will be equal to what? 0. So it's for the instantaneous rate of a function. If the function is a constant at any point in time, will be equal to what? 0. And that ends the first, the solution to the first world problem. Right now, we want to solve the second problem. I will clean this side of the board, and please follow. The second question is y equal to 3x to the power 2. We want to again solve this particular problem using first principle method of differentiation. And there are 2 approaches. And the first approach is the one I'm still talking about. We shall use that first approach to solve this problem. Again, if you follow me up, we have step 1. In step 1, we find f of x. find f of x, and of course our f of x is equal to y, and y is the function given to us, 3x squared. So the first step, you find the function, and the function will be given to you. The second approach, the second step, you find f of x plus change in x. That means to get this, you have to replace x by x plus change in x. What is f is f, but this x now has been replaced by x plus change in x. So that means in this particular function, you replace x by what? X plus change in x. So if I do that, I will have f of x, which is equal to 3x squared. I will now replace this x by x plus change in x. So I will no longer have only x, plus it's now going to be x plus change in x. And I will change this, no longer x squared, but x plus change in x all squared. As you can see, the value of x has been replaced by x plus change in x. And the output is now something that resembles this, only that x has been replaced by x plus change in x, all squared. So the next line of action is to expand this. We want to expand that now, and then move to the next step. If we expand this, we have equal to 3 into x plus change in x, but because I have square here, I will still repeat this, x plus change in x. So 3 into x plus change in x, x plus change in x. It's the same thing as this because I have square here. If I had 3 here, then I would have written x plus change in x 3 times. Since I have 2, I stopped at the second one. So right now, I will expand. To expand this, it means I will times x by this x, times x by this. Then I will equally times delta x by x, times this by this. So if I times this by all, I should say times this by all in the first bracket, times this by all in the first bracket. And that is what is called the left distributivity law. If we times to have x times x is what? X squared. X squared. X times change in x is not change in x all squared. Take note, some students make that mistake of timesing this x by this x. No, it's wrong. This is completely wrong. The right thing is you write this x first and then write change in what? X, because this is another quantity. So we have times x by all the expression in the second bracket. We will again times change in x by all in the second bracket. That means change in x times x is x change in x. And then change in x times change in x is equal to change in x all what? Squared. So I've expanded this bracket. But let us simplify one step further and have this as x what squared plus x change in x plus x change in x is 2x change in x plus change in x all what squared. Alright, I've simplified the expanded expression. Next, I will clear the bracket since I still have 3 outside. So 3 times x squared is what? 3x squared. 3 times 2 is what? 6x. Change in x. 3 times this is what? 3 change in x all squared. So I've expanded this particular bracket by times 3 by everything inside. So what have I gotten? I've gotten f of x plus change in x. And of course it is 3x squared plus 6x change in x plus 3 change in x all what squared. Alright, I've so far gotten f of x plus change in x, and I'm through with step 2. Do not forget that once you replace x by x plus change in x, and you have an output, the output needs to be simplified further. And that is what I've done by expanding x plus change in x all squared. Now we move to step what? Now 3. In step 3, you now find change in y. Don't forget, change in y is simply in functional form is f x plus change in x minus f of x. That means you subtract the last two results of x. F of x plus change in x, we have already gotten that. Look at it here. So I'll replace it here. This is equal to 3x squared plus 6x change in x plus 3 bracket change in x all squared minus, I have the minus sign here. Then f of x is the function given to you, which is 3x squared. So we have subtracted, we want to take common terms. So this and this are common terms. And so we have to subtract the common terms. And if we subtract, this will cancel out. This will cancel out. What is now left? 6x change in x plus 3 change in x all squared. I've gotten my delta y. And that ends step 3. When you subtract, we have change in what y. We now move to step 4. In step 4, you will now find what is called rate of change. Step 4. In step 4, you find rates of change. So how is one function changing with respect to the other rate of change? And then, so to get the rate of change, very, very simple. You find change in y upon change in x, which of course is equal to change in y. We have what in x? I'll write it now. This x change in x plus 3 change in x all squared all over change in what? X. So I've gotten the rate of what? Change. Now we'll now move to step 5, which is the last step. Remember what we are doing? We are differentiating the function y equal to 2x squared, sorry, 3x squared with respect to what? X, using first principle. That is what we are doing. We are now in step 5. In step 5, we now find dy dx, which is the instantaneous rate of change. And you find dy dx, which is of course the instantaneous rates of change. That is what we are looking for. Each time they are asked to find dy dx, they are telling you to find instantaneous rate of change. So if we continue, we have dy what? Dx. Dy dx, I hope you are saying that. Dy dx is limit of change in y upon change in x as change in x approaches 0. This will equal to, maybe I should write this on top so that you see it very, very clearly. We want to find dy dx. So dy dx is equal to limit of change in y upon change in x as change in x is approaching or tending towards 0. Of course, this result we have gotten, this quantity here, we have gotten it as, we have it here as what? Limits of 6x change in x plus 3 into change in x all squared. I should claim this very well. S squared all over change in x as change in x approaches 0. As change in x approaches 0. So at this point, we want to find the limit of this function. Once you find the limit of this function, you have gotten the derivative of the function with respect to x. So we'll start. To find limit of this function, notice that if I substitute, or to find limit of this function, anywhere you see change in x, you are to replace change in x by what? 0. That means 6x times 0, let me write it here, times 6x into what? 0, plus 3 into 0 over what? 0. Of course, this will give me 0 upon 0. This type of answer is called indeterminate form. And to find indeterminate form, you have to carry out 1 or 2 mathematics. And the mathematics here is you factorize. Notice that delta x is here, delta x is here. So we'll factorize by bringing out delta x, and I'll do that now. Limits of change in x all over 6x plus 3 change in x. Since I have removed one change in x, I have square here, I've taken one out, so I only have change in x all over change in x as change in x approaches what? 0. I can cancel this. This is the common factor, I cancel out. And so we have this as equal to, let us substitute now. I have change in x approaching 0. I don't have change in, let me write limits of 6x plus 3 change in x as change in x approaches what? 0. So at this particular juncture, we want to get the limit of the function. And once I get the limit of the function, I've differentiated y equal to 3x squared with respect to x. And to do that, anywhere I see change in x, I will simply substitute 0. Looking at the function closely, you'll see that there is no change in x here. So I'll leave that alone. I'll leave that 6x since I don't have the change in x. So I come here, I saw change in x, 3 into. Change in x is what? 0. So I have what? 0. Since I have change in x. This is equal to 6x, and 3 times 0 is equal to what? 0. And what I'm putting here is dy dx. So far, what have I done? I've done this. If y is equal to 3x to the power 2, then dy dx, which measures the rate at which this particular function, which is 3x squared, is changing at any instant, is equal to 6x. And 6x becomes the instantaneous rate of change. And that comes to the conclusion of the solution of the problem. We have solved problems on differentiation using first principle. So in lecture 03, we shall still continue with differentiation from first principle. We shall take a more tougher problem on differentiation from first principle. Thank you very much.